Welcome to Spaceverse, your portal to cosmic adventures. Voyager 1 holds the remarkable title of being the most distant human-made object from Earth, having journeyed through the vastness of deep space for nearly 50 years. Launched in 1977, this iconic spacecraft continues to amaze scientists and enthusiasts alike with groundbreaking discoveries and the inventive solutions devised by its dedicated engineering team. Recently, however, Voyager 1 encountered a significant challenge when a crucial set of thrusters, which play an essential role in maintaining its orientation toward Earth for communication, began to fail. To tackle this pressing issue, engineers at NASA's Jet Propulsion Laboratory made the strategic decision to activate a backup set of thrusters that had remained unused for many years. In this video, we will delve into the intricacies of this thrilling maneuver, explore the science behind it, and underscore its significance for the future of space exploration. One of the primary challenges that Voyager 1 faces on its interstellar journey is the failure of its thrusters, which are vital for keeping the spacecraft properly oriented toward Earth. After nearly 47 years of continuous operation, these thrusters have started to malfunction, primarily due to fuel line clogs caused by byproducts from aging fuel tanks. This clogging poses a significant threat to Voyager 1's ability to maintain its alignment, which is crucial for ensuring reliable communication with Earth. A loss of communication is a critical concern, as the spacecraft depends on its antenna to transmit vital data back home. In addition to the thruster issues, Voyager 1's nuclear power source has been gradually depleting over the decades, leading to a limited power supply for its onboard systems. As a result, engineers at JPL must carefully evaluate which systems to keep operational in order to maintain the spacecraft's functionality. Recently, in an effort to conserve power, they made the difficult decision to deactivate some heaters, which increases the risk of damage to essential components that are crucial for the spacecraft's operations. The challenge of balancing power conservation with the need to protect vital systems adds a significant layer of complexity to the already demanding task of managing this historic mission. The issues with the malfunctioning thrusters intensified the challenge faced by the Voyager 1 team. With power levels running low, every command had to be executed with extreme precision. Without functioning thrusters to maintain the antenna's alignment with Earth, Voyager 1 would be unable to phone home and transmit its scientific data back to MissionControl. In 2018, when the second set of attitude thrusters also began to fail, engineers were compelled to switch to a backup set designed for trajectory correction. Unfortunately, this backup set started to show signs of clogging as well, leaving engineers with only one viable option, a dormant set of thrusters that had not been utilized in decades. Making the decision to switch back to this older set of thrusters was not without its risks. These thrusters had been inactive for years and were extremely cold, which meant that rapidly warming them could potentially lead to significant damage. The team at NASA's Jet Propulsion Laboratory approached this complex issue with caution and care. After conducting a thorough analysis and meticulous planning, they opted to activate one of the spacecraft's heaters for just 1 hour, allowing them to gradually bring the thrusters up to a safe operating temperature. On August 27, 2024, their careful strategy proved successful. Voyager 1 was able to reorient itself toward Earth for the first time in 6 years, allowing the spacecraft to continue its vital mission of relaying valuable data from the far reaches of space. The success of this operation highlights the remarkable skill and ingenuity of the engineers at NASA's Jet Propulsion Laboratory, who faced the unique and daunting challenges associated with operating a spacecraft that is so far from Earth and has extremely limited resources at its disposal. This level of remarkable adaptability and resourcefulness is not something new for the JPL team. It has been a hallmark of their work throughout the years. As the challenges have evolved, the engineers have consistently confronted these new obstacles with the same high level of precision, creativity, and determination. One notable example of their ingenuity occurred when a chip in the flight data subsystem malfunctioned. This malfunction was likely due to cosmic radiation exposure or simply the natural aging of hardware components that have been operating for decades. Faced with this technical setback, the engineers had to devise a solution that involved transferring the corrupted code to different memory locations while simultaneously modifying it to ensure compatibility with the system's existing architecture. This was no easy feat, especially considering the limited memory available on the spacecraft and the absence of modern testing tools, which would typically aid in debugging such complex issues. The task required meticulous attention to detail. The team divided the code carefully and updated all necessary references to ensure that everything functions smoothly, showcasing their exceptional ability to manage and troubleshoot outdated systems in the harsh and unforgiving environment of deep space. Similarly, the issue of thruster clogging has posed a persistent and ongoing challenge for Voyager 1 throughout its historic mission. This particular problem first emerged in 2002, which led the engineering team to make a critical decision to switch to a backup set of thrusters to maintain the spacecraft's functionality and orientation. Unfortunately, by 2018, this backup set also began to exhibit signs of failure, forcing the engineers to adapt once again and find innovative solutions. Their ability to switch between systems seamlessly and repurpose equipment that was not originally designed for specific tasks has proven crucial in extending Voyager 1's mission far beyond its initial objectives and expectations. Recently, the team once again tackled the ongoing thruster issue, demonstrating their unwavering ingenuity and steadfast commitment to keeping the spacecraft operational despite the myriad challenges it faces. This resilience not only speaks to their technical expertise, but also embodies the spirit of exploration that defines NASA's mission in deep space. Voyager 1's journey has also encountered various other technical obstacles. In 2022, the spacecraft began sending back unintelligible data to Earth due to a malfunction in the attitude and articulation control system. This critical system inadvertently routed telemetry data to the wrong computer, causing significant confusion. With no ground-based simulators at their disposal and much of Voyager's documentation still in paper format, engineers faced a daunting task in diagnosing the issue with limited data. They implemented a low-risk solution by instructing the AACS to redirect the data to the correct computer, successfully restoring normal transmission and underscoring their problem-solving skills. Power management has emerged as another ongoing issue for Voyager 1. The spacecraft relies on a nuclear power source that gradually diminishes over time, leading to a reduced power supply for its systems. In an effort to conserve energy, engineers have had to deactivate non-essential systems and even some heaters. These heaters are occasionally turned back on to warm critical components, preventing damage from cold temperatures. Maintaining this delicate balance of power management is vital for ensuring the spacecraft's continued functionality as it travels deeper into space. Communication challenges have also presented significant hurdles for the Voyager 1 mission. Given the spacecraft's immense distance from Earth, it takes approximately 22.5 hours for a signal to travel one way. This long delay makes troubleshooting efforts extremely time-consuming and complex. In 2023, the spacecraft faced a data transmission issue caused by a malfunctioning chip in the flight data subsystem. This problem resulted in garbled data being sent back to mission control. Engineers responded by relocating the software code to different areas of memory, demonstrating their innovative approach to managing aging hardware and their commitment to overcoming the obstacles presented by deep space operations. Looking ahead, NASA aims to keep Voyager 1 operational until at least 2027, coinciding with the mission's momentous 50th anniversary. However, as its power supply continues to dwindle and the spacecraft systems become increasingly vulnerable to failure, each additional year of functionality is considered a significant achievement. Engineers are now focusing their efforts on essential systems, strategically shutting down non-critical instruments to conserve power and prolong the mission. This cautious approach underscores the challenges of managing a spacecraft of such advanced age in a harsh and unforgiving environment where any new issue could pose a critical threat to its continued operation. As they navigate these complexities, the team remains dedicated to maximizing the scientific returns from Voyager 1, ensuring that it can keep sending back invaluable data from the far reaches of space. And that's it. Thanks for joining us in Spaceverse. Today, we explored Voyager 1's incredible journey and its triumphs over challenges. Don't forget to like, share, and subscribe for more exciting stories from our universe. Stay curious and see you next time.